Okay, okay. Now we are here in Stella and we're going to build our model. We will begin by clicking this rectangle right here. This is a stock. This stock is going to represent compound A and we're going to label it with A. And we're going to give it a value of 1000. Now we need to represent compound B, so we click again the stock icon and we're going to label again B and we're going to give it a value of 0. So now we have our two compounds and we just need to say to the model that compound A will transform in compound B. To do that, we're going to click this icon right here that says flow and we're going to click over A, above A, and we're going to drag and drop above B. This flow will represent our reaction. Okay, now the only thing that we are missing right here is the reaction rate that will that is the time that will take A to become B. So now we're going to click right here on converter and add it to our canvas and we're going to name it rate constant K. Okay, and at last we just need to connect everything. So we're going to click right here in action connector and we're going to click above rate constant, drag and drop to reaction. Now we're going to click it again and click A, stock A, and drag and drop to reaction. Notice that I missed to give it a value to the rate constant, and this is going to be 1e to the minus 3. In order to have a result that is similar to what we have in a lab, in an experimental lab, we need to use the best integration method, that is Ranch-CUDA 4. So to do that, we're going to go to run specs, and we're going to do some change right here. We change the integration method to Ranch-CUDA 4. We're going to need a delta t, a small delta t, like 0.01 or smaller, and we're going to give it some time. So we're going to simulate 48 minutes, and we're going to say okay. Now we only need the reaction formula. For that, we're going to click on reaction and then select the rate constant K, and this will multiply A, and that's all our model. We now just need an interface. For the interface, we need to go right here, interface, and we're starting by adding a graph path by clicking this icon right here, this green icon. We click, then click, that would be our graph path. We lock it with this pin right here, we pin it, and then we just going to do double click, and then select A, and then select B, or two compounds to see what's going to happen. And that's the only thing we need right here. Now we need an a table path. This table path will allow us to see the graphical, will allow us to see the results in a text mode. So clicking right here, notice that the page just grew larger, and we're going to do double click and then select A, B reaction in rate constant K. That's all the values, and we're going to give it a name. And it's chemical kinetics table 1. We're gonna hit OK. So right here are our value or variables, and we only need two more things to finish. We're gonna click here on this question mark, and this will add a button. We need to run this model, so we're gonna select menu, then run, and then OK. This will be a run button. We're gonna give it some little big, and now we're gonna hit this icon right here, this that says slider input device. We're gonna click it right here. Now we're gonna select rate constant K. We're gonna give it a value is 0.001, and we're going to give it a max number of 0.1, and the free float would help. We could change here, give it a small slider, it would show the name, and okay, we have actually finished. Now we need to run this model, and we just need to click this button here, and it shouldn't fail. So let's see. Right here says the time that takes to this simulation to run, and this is the result. Notice that compound A, that is the blue line right here, has been transformed to compound B, and so A has an exponential decrease, and B has an exponential increase of B. So this is our model, and we now can play. We could do a little adjustment right here and click not every dt, but instead like 4 dt's, and then run it again, and that will give us a smaller table in order to see your final result, but that's up to you. Well, thank you again, and see you next time.